Okay, so good afternoon, class. Last time we had tackled about the introduction of the Earth science. As a recap, Earth science is the name for all the sciences that collectively seek to understand Earth and its neighbors in space. So there are four only basic areas of Earth science. The first one is the astronomy. It talks about how the Earth relates to space and time. The second one is the meteorology. It talks about how the atmospheric conditions relate to weather and climate. Third one is the oceanography. It shows us how the marine ecosystems interacts to the ocean. And the fourth one is the geology. It addresses how the Earth's landforms and rocks change over time. We have tackled also the earth science, people, and environment. It says that how the people interact to the environment. So we also have tackled um, the natural hazards, the natural resources, and the population growth. So now our topic is all about the Earth spheres, structures, and interactions. So class, what can you say about in this image? So, okay, nashi four ka-elements. Okay, very good. So, Earth is the only planet in the solar system capable of supporting life. Complex and brilliant combination of gases, composition, and structure of Earth are some of the reasons why it can sustain life. Earth is a very complex place. Earth is the fifth largest planet in the solar system. It's the smaller than the four gas giants, which is the Jupiter, Saturn, Uranus, and Neptune, but larger than the three rocky planets, which are the Mercury, Mars, and Venus. So, what are these different spheres? On the image, we see the following key elements that represents Earth, mainly air, water, and land. These key elements comprises of what Earth is today and even in the past, and also in the future. And because of these key elements, our Earth won't be the Earth as we see it today and observe today. Now we will be talking mainly about these following spheres: the atmosphere, the geosphere, the hydrosphere, and biosphere. And all of these spheres are part of the Earth's system. The atmosphere is the part of the Earth system that includes the mixture of gases that surround the planet. The geosphere is part of which includes the internal layers of the Earth, which are the crust, mantle, and the core. The hydrosphere, on the other hand, is the part which talks about the planet's water, including the surface waters, groundwater, i- ice, salt water, and water vapor. Lastly, we have the biosphere that includes all the living things, including plants, animals, and other organisms. So, class, can you still remember the layers of the Earth? Okay, very good. The geosphere describes all of the rocks, minerals, and ground that are found on and in Earth. The geosphere is divided into three main parts: the crust, mantle, and the core. This includes all of the mountains on the surface, as well as the liquid rock in the mantle below us and minerals and metals of the outer and inner core. The continents, the ocean floor, all of the rocks on the surface, and all of these sand in the deserts are all considered part of the geosphere. Basically, if it looks like solid ground, it's part of the ground sphere. So let's time this time let us recall the internal layers of the Earth, basically its inner structure. The planet Earth is made up of different layers: the very thin, the brittle crust, the mantle, and the core. The mantle and the core are each divided into two main parts. Although the core and mantle are about in thickness, The core actually forms only 50% of Earth's volume, whereas the mantle occupies 84%. The crust makes up the remaining 1%. We also have the Golden Bridge discontinuity that boundaries the outer core from the lower mantle, while the Mohorovičić discontinuity, or what we call moho, that boundaries also the upper mantle and the crust. What's making it more interesting is that each of these layers has its own different physical characteristics and composition. Layers on the left side table are based on differences in composition of each layers, of which the crust is composed primarily of silica plus light metallic elements. As you go below, it will be still made of silica, but iron and magnesium will now be present. And lastly, the core is made up of iron and nickel. On the other side of the table are its mechanical or physical characteristics. We can observe that the little sphere is composed of brittle, solid part, and underneath it is a plastic, is solid yet nearly liquid as the noosphere. The lower mantle, historically known as the mesosphere, is composed of a solid structure. As we go inside, we will meet the outer core that is in liquid state, and the inner core is in the solid one. Again, the geosphere is the sphere that is mostly solid in a rocky part of the earth that includes volcanoes, rocks, minerals, coal, oil, and coal, oil, and land itself. From the surface, we have the crust that is thin, outermost layer that is made of silicate minerals. The crust is the outermost part of the earth is very thin compared to the other layers. It is a part where the living organisms dwell in. It forms a very thin continuous layers that extends underneath the ocean and continents. That is why we have two types of crust. The oceanic that is 5 to 10 kilometers thick and the continental crust that is 35 to 70 kilometers thick. The continental crust is mostly composed of different types of granites, types of rock. Geologists often refer to the rocks of the continental crust as sigal, which stands for silicate and aluminum, the most abundant mineral in continental crust. On the other hand, we have the oceanic crust, which is mostly composed of different type of basalts. Rocks of the oceanic crust are composed of are referred to as SEMA, which stands for silicate and magnesium, the most abundant minerals in the oceanic crust, and the oldest of which are called cratons, and it is the most stable part of the continental lithosphere that are found deep in the interior of most continents. We'll jump now to the mantle. This is the part of the earth that is the mostly solid book of earth's interior that it is made of very slow flowing solid rock consisting of silicate minerals that are denser than in the crust. The mantle lies between earth's dense superheated core and its thin layer, the crust. It is made up of silicates, magnesium oxide, iron, aluminum, calcium, sodium, and potassium. The mantle is divided into two layers, the upper mantle and the lower mantle. Earth's crust on the mantle, much as piece of wood, floats in water. The slow motion of rock in the mantle shuffles continents around and causes earthquakes, volcanoes, and the formation of the mountain ranges. So below the mantle is the Earth's core that is about 7,100 kilometers wide and 3,500 kilometers in radius, which is the denser and hottest part of the Earth. The core is made almost entirely of iron and nickel. The outer core is liquid layer of 2,260 kilometers thick. The core is responsible for the planet's magnetic field, which helps to deflect harmful charged particles shot from the sun. And it is the At it in this layer that we can find the movement of metallic iron that generates Earth's magnetic field. The inner core is also dense ball of iron. The temperature of the inner core is far above the melting point of iron. Despite its higher temperature, the iron in the inner core is solid due to the immense pressures that exist in the center of the planet. Okay, class, I want you to analyze what are the rules of the geosphere. What does it contribute to the Earth system as a whole? Okay, thank you. So the geosphere is very important since it is the contributor of particulate matter and atmospheric gases to the atmosphere, and also it is a the contributor of salts to the ocean to to maintain the salinity. Also, it is the ultimate source of nutrients for all living things. Because our planets, because our plates are moving, the geosphere produces barriers that aid in the isolation of population of organisms, therefore influences evolution. So, planet Earth has been called the blue planet due to the abundant water on its surface. Over 71% of the surface area of the Earth is covered by water. All of all the Earth's waters, solid or in liquid form, those that are contained in glaciers, rocks, soil, and the air, comprise the Earth's hydrosphere. By its definition, the hydrosphere is the part of Earth that is liquid water. About 97% of Earth's water exists as salt water, while the remaining 3% is fresh water contained in glaciers, lakes, and rivers, and beneath the Earth's surface as ground. Only a fraction of Earth's total amount of fresh water is in lakes and rivers. Water on Earth is constantly moving. It even moves into and out of living things like we need water to live and we excrete it afterwards. When we say about the water is moving, we are talking mainly about the hydrologic cycle. Water on Earth is continuously moving. It endlessly circulating through the hydrologic cycle. As water goes in a cycle, it changes its states from liquid to ice to gas and back again. Sun heats water, causing the water to evaporate. Rising air currents take the water vapor up in the atmosphere. The vapor rises into the air where cooler temperatures cause it to condense into clouds. Air currents move the cloud, then cloud particles collide, grow, and fall out of the sky as precipitation. Most of the precipitation return to the oceans. And because of this water cycle, it generates the different sources of water here on Earth that includes the surface water and the the groundwater. Surface water includes the ocean as well as water from lakes, rivers, and creeks, while the groundwater includes water trapped in the soil, and we have also frozen water that is trapped in the ice caps and glaciers. Only 3% of water distribution are fresh water, while 97% of which are salt water. That is why we need to conserve every water that we will use in order to sustain humanity. Okay, again, class, what is the rule of the hydrosphere? Same with the geosphere, the hydrosphere also is a vital and important since it is the one who moderates every climate on Earth. It also transfers heat and energy. Living organisms also need water to transport nutrients and waste in order to survive. Water overall is essential in many of the Earth's processes, from mineral formation below the ground to everything that it touches on the surface. So we have the third one, that is the atmosphere. This is a very huge envelope of air that surrounds the Earth and pulled by the gravitational force of the Earth. The Earth's atmosphere is primarily composed of 78% nitrogen and 21% of oxygen. Other gases like argon, carbon dioxide, carbon monoxide, oxygen, hydrogen, helium, and other inert gases make up the remaining 1%. Earth's atmosphere provides oxygen for living things, protects Earth inhabitants from harmful radiation from the sun, and it helps to keep the planet as at a temperature suitable for life since it drops some energy from the sun, which helps keep Earth warm enough for living things to survive and multiply. Some gases of the atmosphere absorb and reflect harmful ultraviolet rays from the sun, protecting Earth and its living things. The atmosphere also causes space debris to burn up before reaching Earth's surface and causing harm. So basically, it is a defense barrier mechanism that protects us from the visitors outside. The atmosphere reaches over 350 miles up from the surface of the Earth. It is made up of different layers as shown in the image. In the lowest part, we have the troposphere. From the word troposphere, from the word tropo meaning change. Thus, it is the part of the atmosphere and where there is a weather, there are changes in the atmosphere itself. This is the part in which air is closest to Earth. This is the area on which we live and where weather is formed. Airplanes and other aircrafts fly at the top of it. It is located 0 to 10 kilometers from the ground surfaces. The next layer is the stratosphere. From the word strato means layer or level. This layer lies above the Earth's weather and mostly changes very little. It contains the ozone layer, which shields us from the sun's ultraviolet radiation, except where it's being harmed by man-made chemicals. Above the stratosphere, we can find the mesosphere. This is the coldest layer, and the meteorites break apart here. This is where diffuse atmospheric components are found. Thermosphere, the next layer, lies above the mesosphere. It is 5 times deep as all other layers combined, and it is very hot layer that holds up to 2000 Celsius because as you go farther away from the ground, the atmosphere will become thinner. Lastly, we have the exosphere, from the word exo meaning outside. This is the part where satellites circle the Earth and this beyond 300 miles above the surface of the Earth. So the rules of the atmosphere. Like the geosphere and hydrosphere, the atmosphere serve as serves as barrier that protects the Earth from the outside visitors. It acts like a shield that disintegrates every object that is coming inside of the planet. One thing is that it contains the gases that living things need for survival. For example, carbon dioxide for photosynthesis and oxygen for respiration. It also transfers heat that is coming from the sun. The ozone layer that is found on the stratosphere protects living things from excess harmful ultraviolet radiation. Lastly, it plays a part in weathering and erosion on the surface of the Earth. The least we don't forget is the part of which life is located. We have the biosphere. The biosphere is where all forms of life exist. Since life exists in the air, in water, and on the ground, its boundaries overlap over sphere because life can be found everywhere on Earth. The biosphere is sometimes thought of as one large ecosystem, a complex community of living and non-living things functioning as single unit. It includes all organisms on Earth as well as the environments in which they live. Most organisms live within a few meters of Earth's surface, but some exist deep beneath the ocean surface, and others live high atop Earth's mountain. And all of the life forms requires interactions with at least one of the other systems for their survival. Because of this, biosphere is structured into a hierarchy known as a food chain in which energy and nutrients like carbon are transferred from one level of the food chain to the next. So the rule of the biosphere is here in biosphere it aids in weathering and an important sink for certain elements, especially carbon. It also mitigates the formation of some minerals and processes like photosynthesis, maintains the oxygen content of the atmosphere for the living things to survive. In the smallest sense, we can call the biosphere as our home. Now we will tackle more of its interactions from one sphere to another, like what we have always been doing on the social media. We humans, on the other hand, are communicating with each other around the globe through technology. We are likely connected through the internet and other social media applications like Facebook, Google, and YouTube. It is more likely the same as what we are doing right now since I am communicating with all of you and discussing new things about Earth. The Earth also has its own way of communicating itself. It's not just as humans, but everything here on Earth works hand in hand. Everything is being connected with each other so that it will be an equilibrium and for it to have the balance to sustain the planet itself. Likewise, the four major spheres on Earth are governed by the series of processes that are interconnected, and it plays a vital role to make planet Earth work as a whole. With all of these spheres that interact with our planet, we can conclude that our planet is a complex system made of living and non-living things. And matter and energy continuously cycle through the smaller systems. The Earth system the Earth system is all of the matter, energy, and processes with Earth's boundary, and these are groups of related objects of parts that work together to form a whole, which means it cannot stand alone and it needs the other sphere to make the others work. In short, all of these spheres are interconnected and it acts like the clockwork. Now let's try to relate it with the present. Why it is called a system? Let us try to analyze by this scenario. Now I have a picture of a snake plant. These are the variables that makes it alive. We have the sunlight, land, water, and air. What if there will be a lacking variable? Will the plant survive? Of course it won't, since it needs those variables to grow. As you can see, the plant that lacks any variable will not survive. Thus, it needs the primary elements for it to survive. So basically, everything is connected and acts like a system that works together to form a whole. Based on the image below, why do you think Earth as a system works like a clockwork? What will happen if one gear will not work? What will be the consequences? So, this time, we'll picture our Earth as one whole working body since it works in a systematic way. The Earth system is all the matter, energy, and processes within Earth's boundary that continuously cycle through the smaller systems. When we talk about system, it means that a group of related objects or parts that work together to form a whole. For example, working with your group mates in an activity. You are working with each other to accomplish something, and that reflects our Earth. All of these spheres of Earth interact as matter and energy, change and cycle through the system. A result of these interactions is that they make life on Earth possible. Earth's spheres interact as matter moves between them. In some processes, matter moves through several spheres. The main source of energy comes from our sun, and we have also the internal heat that is given off by the planet itself. After seeing everything that we have discussed, we have concluded that everything around us is connected to one another. For example, many birds fly through the air. When you say birds, it talks about the biosphere. When you say air, it talks about the atmosphere. While water often flows through the soil. Water talks about the hydrosphere, and soil, it talks about the geosphere. In fact, the spheres are so closely connected that a change in one sphere often results in a change to one or more of other spheres. One small problem can lead in, into other big problems and will turn out just like a domino effect. So this is an actual photo during the eruption of Mount Pinatubo on June 15, 1991. As we can see, the eruption is being generated in the geosphere. And in this case, Mount Pinatubo is releasing huge clouds of volcanic ash that rises above its crater. And the eruption is considered the second largest volcanic eruption on Earth in this century. Here we can observe that the geosphere is generating the event and it has adverse effects to the atmosphere and the biosphere, for which it can displace the living things living in the vicinity of the volcano, and also it can affect the health of people and animals that can lead to death. Moreover, it can also affect the atmosphere since it is giving off mixtures of gases and dust, making the whole Earth's temperature to lower down. We have also earthquakes, one of which of the Bohol earthquake that happened in this year 2013. The event, like the volcanic eruption, originates in the geosphere because of the movement of the plates below the surface of the Earth. When in the fact the Philippines is primarily located in the Pacific Ring of Fire, meaning it is an earthquake prone country. Earthquakes can damage buildings, which may kill people in the biosphere. It can also cause fires, which releases gases into the atmosphere. Moreover, the destroyed buildings can be source of noise pollution and dust pollution that affects everything in the atmosphere and can also be a problem to the people living in the area. Earthquakes can also induce and may cause a tsunami if it will happen in the hydrosphere, specifically on our seas and oceans, that can eventually hit and kill both animals and people. Lastly, we have the typhoons. This is known in the Philippines as Super Typhoon Yolanda. It is one of the most powerful tropical cyclones ever recorded. One making on making landfall, Typhoon Yolanda devastated portions of Southeast Asia, particularly in the Philippines. Unlike the earthquakes and volcanic eruptions, a typhoon originates the atmospheres and collects energy from the hydrosphere through the oceans. These winds then collect moisture and rise, while while colder air moves in below. This creates pressure, which causes the winds to move very quickly. The winds rotate or spin around a center cold and eye and eventually devastates everything in its path. Since it can destroy everything in its way, it can be a problem to the people living in its vicinity. It can affect all the hydrosphere since it can create storm surges and and can also induce floods. It can also affect the geosphere where it can create landslides. After seeing everything that we have discussed, we can conclude that everything around us is connected to one another. In fact, spheres are so closely connected that a change in one sphere often results in a change in one or more other of the other spheres. One small problem can lead into another problems and will turn out like domino effect. With this, we learned that the four spheres, namely the geosphere, atmosphere, hydrosphere, and the biosphere of Earth, drive all of its processes and support life on our unique planet. Material on Earth doesn't stay how it is. It gets recycled into other phases and forms. Plants in the ground die as they are broken down by microorganisms. They become soil, which can then feed new plants. Water cycles through different phases and locations, like when it evaporates from the oceans, then rain downs onto the ground or into a lake. Rock also get recycled under the Earth's surface, where it is melted down and then sent back up in the volcanic eruptions. So that maora to atong discussions class. I hope na amoy na learn sa atong topic for this afternoon. So thank you.